Number 6 is a commonly missed question, and it's really an important one because this is a lot of what we do in Chapter 11 and what we do in chemistry in general. It says, tell how many moles of each element in a compound are present in one or more moles of the compound. And there's some examples on page 981. There's a couple more you could try there. But this is where you have to use a molar ratio. So in this case, when we look at how many moles of each element are found in 3.5 moles of potassium chromate, what I'm being given is 3.5 moles of potassium chromate. So first of all, I need to know what potassium chromate is. It's potassium with the +1 and chromate CrO4 with the -2. So this is K2CrO4. And I have to find each element. So I have to find how many potassium, how many chromium, and how many oxygen, how many moles of each one. So I do the same process. I put what I want on top. So the first one I want is moles of potassium. And what I have, what I've been given, is moles of K2CrO4. So now when I look at my helping hand, my two converters, I can go from moles to particles or moles to grams, but it doesn't tell me anything about moles to moles. That's because the formula tells me. The formula is telling me there's 2 moles of potassium, that's what this 2 is telling me, in every 1 mole of potassium chromate. So I go ahead and take 2 times the 3.5, and I see there's 7 moles of potassium. And then to find this for chromium, I'm going to do the same thing, but now I'm going to put in moles of chromium, and there's just 1. So when I take 1 times 3.5, it's just 3.5 moles of chromium. And I apologize if this is getting messy, but for the last one, I would take my 3.5 moles, and I'd be putting it with oxygen on the top, 4 moles of oxygen. That's not a very good color there. 4 moles of oxygen in every 1 mole of the potassium chromate. So that means I've got 14 moles of oxygen. So that's what you do when you're asked to go from moles to moles. You set up a molar ratio using the formula of the compound you're interested in. And then just an extension question here, how many atoms of oxygen would this be? Well, I've got 14 moles of oxygen. So I can change that to atoms, easy peasy. Atoms on top, moles on the bottom. So I put Avogadro's number on top, the 1 mole on the bottom. And I go ahead and take the 14 times 6.02 and get a big number here. 14 times 6.02 times 10 to the 23rd. So this is going to be 8.43 times 10 to the 24th atoms of oxygen. And sometimes it's important to know our atoms of oxygen because it's going to be a gas, and gases tend to take up a lot more space than a liquid or a solid. So if we have a lot of gas coming out of there, we should know what to do with it. But those are molar ratios.